Welcome to this presentation of Vishay's NTCC201 Enhanced Wire Bondable NTC die series. An enhanced metallization makes this series ideal for integration in power modules like DC to DC converters and inverters. After integration into the core of an IGBT or PowerMOS module, the NTCC201 series of NTC thermistor bare die will watch over the temperature control during the lifetime of this device by tuning down the duty cycle or shutting down the gate driver. Aside from IGBT modules, the 10 kilo value die in the series can also be used for many other boards, for example, thermoelectric modules. NTCC201 die can be mounted on the board by first sintering the bottom electrode and the substrate with solder paste, then being wedge bonded with aluminium wires coming from the wedge pads. This forms the loop that will be used later for the quality pull bond test. It is common practice to protect the component further with a glob top epoxy. The NTCC201 metallization is thick. The outer electrode is a special glass fritz silver paste with dopes for sintering and resistance to leaching during reflow soldering, whether the soldering involves SAC or lead-rich HMP solder material. It is resistant to formic acid, which is commonly used for flux-free soldering when solder preforms are used, and vacuum or forming gases when solder paste is used. The thick metallization is also suitable for nano silver paste sintering under pressure. Vishay provides R25 tolerances down to plus or minus 1%, and the same tolerances for the B values. The combination of these tolerances and the outstanding stability at high temperature will ensure a temperature precision of plus or minus 2.5 degrees C at 175 degrees C. The NTCC201 series is delivered on blister tape and reel for automatic mounting. The enhancement of the NTCC201 series compared to the NTCC200 resides principally in the metallization. A robust electrode enhances the bare NTC to resist all kinds of mountings, reflow soldering cycles and sintering as processed for the silicon die of the board. Thickness is measured by SEM and X-ray Fisher scope techniques, and variations are followed by an SPC process. Like all nonlinear resistor products, the NTCC201 series is design-in friendly. Vishay can provide full ACQ200 qualification test results for each R25 value, as well as some specific ACQ101 tests, like pull bond tests. Resistance versus temperature curves are available from our online calculator, together with SPICE models where the temperature is input as a voltage. We are now going to see an application simulation in LT SPICE of a DC to DC converter derated in temperature with the help of a SPICE model for an NTCC201 thermistor die.
This is a circuit diagram of an half-bridge PowerMOS DC-DC converter with an integrated Vishay NTC die thermistor NTCC201. The switching frequency is fixed by an analog device's LTC4449 gate driver. Due to the switching of the power MOSFETs, heat is generated, causing the module temperature to increase. This heat is ejected into an RC thermal circuit, which represents the heat sinks of the power module. The temperature of the heat sink is measured by the NTCC201. Starting from a threshold fixed by this PWM circuit, the switching duty time of the DC-DC converter will be decreased. This will keep the module under a temperature limit. We will now visualize this limit with a series of transient simulation with increasing initial temperatures. We plot the temperature variation compared to the initial value. As the initial temperature increases starting from 40 degrees C, we see on the upper pane the derating in voltage on the load. The further temperature rises on the lower pane, at a point the temperature curve is inflected and begins to decrease. At this level, the amount of heat generated by the switching is totally dissipated into the heat sink. Plotting it into the SPICE log file, we see that the temperature rate of rise is here 0 for a temperature of 82 degrees C. Thus, that is the steady state temperature.
This infographic sheet summarizes the quintessence of the NTCC201, a component series designed with a robust metallization, resistant to all kinds of processes present in IGBT/power MOSFET module manufacturing. Generalization of reliable temperature protection with the NTCC201 series will ensure the long-term reliability of power modules in automotive and other applications.